Welcome to section 12.2, Moving and Additivity Principles about Area. Here are our topics, our objectives. We're going to be in grade 3 and our vocabulary. So how do you figure out the area of a shape? Well, of course, your first thought might be to look for a formula, but area formulas work as well as reasoning, and these are based on the areas. These are based on the principles of area. So we're going to study two fundamental principles that are used in determining the area of the shape. And they're pretty much common sense. And students in elementary school use these, but maybe don't realize they're using them. So the first one is the moving principle, that if you move a shape without stretching it, then the area doesn't change. So we're allowed to move shapes as we try to figure out the area. The next is the additivity principle, and that's if you combine shapes without overlapping, then the area of the resulting shape is the sum of the shapes. So that means we can kind of move things around and combine. So just as the properties of arithmetic allow us to take numbers apart and calculate the pieces, we can do the same thing with shapes. We can take them apart and calculate the areas of each piece. So a common way to use the additivity principle is to subdivide the shape into pieces whose areas are easy to determine, and then add the areas of the pieces. So the resulting sum is the sum of the original shape. Let's look here. So if we've got this shape here, for example, the area of the surface area of a swimming pool. To answer this question, we could divide the surface into two rectangles, right? And maybe you're thinking, why did they do this? Couldn't they have done this? And the answer is yes. There are lots of different ways to subdivide and to break things apart. You could also, do this, and if you want to do more, you could do that too, right? We probably want to subdivide it into the least amount, but there are lots of different ways to do this. Ooh, excuse me. So in this case, we have this piece here, and we know that this is a 16 by 28 rectangle, and we know that this is a 20 by 30 rectangle. So when we multiply those two, remember order of operations, always multiplication first. You don't need parentheses because the order says multiply before add, but we will multiply those two first and then add them together. Let's do an example. So this is a floor plan for a one-story house. So we can calculate the area of the floor of the house, and we need to explain our reasoning. So there are lots of different ways to divide this up, but what I'm going to do is I'm going to divide it, let's see, I'm going to divide it here, and then I'm going to divide there. Okay, so I've got 1, 2, 3, and I'm actually not going to use numbers because I don't want to confuse us. We've got A, B, and C. So A here is 24 by 40. So I know that's going to be 24 times 40 plus. Now, I know that this is 24, but I need to figure out this little piece here before I can move on. So let's see here. I know that this full length here is 40, and I know that this full length here is 32, and this is 24. So let's think about this for a minute. Let's look at just this piece because we're talking here. So this is 32, and we know that this piece is 24. So we actually don't need this 32 because we know that 24 plus something gives us 40, right? So 24 plus 16, because these two pieces need to add to 40. So this rectangle is 24 by 16. And then over here, we've got 40 by 32. So we would multiply all those up, we would add them together, and we would get 2,624 square feet. Now, is that the only way to divide this? Absolutely not. There are lots of different ways, but here it is written out for you as well. You go ahead and give this a try. Press play when you're ready to see the solution. Now let's apply the moving and additivity principles. So another way to use these is to determine the area of a shape and subdivide it into pieces, and then move and recombine them without overlapping. So here's an example. We have this kind of bump here, and we have this empty space. So we could take this bump and move it into this empty space, and voila, we've got a rectangle. We can also take away area. So in this example here, we have the area of this rectangle, and then we want to take away the area of this rectangle. And so we can say, all right, well, A plus B, this plus this is equal to the full area, which is 5 by 3 or 15 square centimeters. So that's 15 square centimeters, take away the area of B. And then we can find B and figure that out as well. So let's do an example. So here's a floor plan. Bob calculates the area of the floor this way. He says 36 by 72 minus 18 times 18. What might Bob have had in mind? Explain why Bob's method is legitimate and explain clearly how one or both of the principles were applied. All right, so if he did 36 by 72, I know that he multiplied these two, and that is that big rectangle. So Bob started, he viewed it as a rectangle. And then what's this 18 by 18? So he must have subtracted these pieces, but these look like triangles. Where did he get 18 by 18? That's 18 high. That's 18 high. So maybe he took them out and thought about them like a square. So then he thought about it as a rectangle with two triangles cut out that make an 18 by 18 square. So that is what Bob had in mind. So why does that work? Well, it works because of the additivity principle here. He used the takeaway method, the idea that these are equal if you take them away, and we didn't stretch or shift or change the area in any way of those triangles. We just moved them using the moving principle. All right, let's continue here, and now we'll determine the area of the shape. We're not allowed to use any formulas other than the area of a rectangle. So we can't use any triangle formulas or anything like that. All right, let's take a peek here. Well, I'm going to look at this as a big square. This is a 2-inch square. So I know that I'm looking at a 2 by 2 inch square. Now, what have I got going on here? So I have to use rectangles. So this is 1/2, and that is 1/2. And so I've got this kind of side over here, and I've got this side over here. This, let's call that A. Let's call that B. So maybe that's C. Maybe that's D. So if I put these all together, I'm going to get a square that this side here is 1/2 inch. So this is I need to take away a 1/2 by 1/2 square. And then what is this? What have I got over here? So this, if I cut this in half, these are just two of those triangles, right? Like it's just this triangle, maybe that's A and B. So then I need to, so what's the area here? I need to take away, this is 1/4, 1/2 by 1/2 inch squared. So I need to take away that. And then I need to take away half of that. I need to take away half of that because this is 4 pieces and I need to take away 2 pieces. So half of that is 1/8. Half of a fourth is an eighth, or 1/2 times 1/4 is 8. So 2 times 4 is 8. So then I've got, okay, 2 by 2, that's a 4-inch square. So I've got 4 square inches minus 1/4 minus 1/2. So that is going to be 3 5/8 square inches. Go ahead and give these 2 problems a try. Press play when you're ready to see the solution. And that concludes this section.